Hello, you're welcome back. All right, still on work, energy, and power. Here we are going to be looking at some problems and solutions. So we'll apply all the formula we've already learned, okay, to the solution to solving of some typical examination questions. So I will start with the very first question. All right, here the question is on the screen. It goes this way. A body of mass 4 kg is acted on by a constant force of 12 Newton for 3 seconds. Okay, so I read the parameters. This body, the mass of this body is 4 kg and the force acting on this is 12 Newton. 4 kg and the force acting on that body is 12 Newton. And that the time for this force to act is this force acts for 3 seconds. So now the question is, the kinetic energy gained by the body at the end of the time is, so kinetic energy, okay, Ke or K, all right? Let me just use K. So now, if I want to calculate the kinetic energy, of course, by the formula, all right? Kinetic energy is simply half mv square, okay? Now, I know my mass, but I don't have my V. How do I get my V? Right, V is not here, so force was given and time was also given, so invariably I need to get my V from Newton's second law of motion. Remember, okay, Newton's second law of motion, we have that force is always equal to change in momentum, mv minus u, then divided by the time t. Okay, so how would this work for me? How will it work for me? All right, so now I will use this particular formula to get my V. Now, what of my U? For all indication, this particular object actually started from rest. This object was acted upon, okay? So in a case where you are being given a question and it wasn't stated that the object started from rest, it should be noted that every object was a force is applied, okay? And we are actually looking for the final velocity, okay? It should be uh, even if it was not stated, you should know that that particular object start from rest and of course from rest. Okay, the initial velocity is equal to 0. So from here now, we have the force being 12 Newton. Then the mass is 4 kg. Of course, what I'm looking for is velocity minus the initial velocity, which is 0, then divided by the time 3 seconds. So I will have to cross multiply. Cross multiplying now. So what am I gonna have? V minus 0 is V. V times 4 is 4V. 4V times 1, I'm having 4V here, right? So here I have 12 times 3, which should give me 36. So for what I have here now, my velocity is gonna be 36 all over 4, which of course is 9. Yeah, 9 meter per second square. Okay, so having gotten my velocity, I can now evaluate the kinetic energy. That's half times the mass. All right, the mass is 4, then multiply by the velocity. Velocity square, 9 square. So with what I have here, now my kinetic energy now is gonna be equal to half of 4 divided by 2 is of course is 2. That's 2 times 9 square is 81. So 2 times 81, that's 162. So the kinetic energy is 162 joule. All right, I hope that is well understood. Okay, so next question. Next question. Let me clean up. Okay, so let's pick another question. Here we go. So I got to maximize this. This one goes this way. If water pump at Kainji dam is capable of lifting 1000 kg of water through a vertical height of 10 meter in 10 seconds, the power of the pump, right? So since we are looking for the power, so we are looking for the power is going to be equal to the work or the energy, okay, the potential energy expended by lifting that water to that height. That's energy all over time, and potential energy is mgh, of course, divided by time. So from what we have here, mass is 1000 kg and the height is 10 meter, time is 10 seconds. So that's going to be 1000 kg times g, acceleration due to gravity is 10, and the height, we are told the height is 10 meter, then divided by the time, which of course is 10. Okay, of course, my power now is going to be equal to 10,000 watt, okay, or 10 kilowatt. 10,000 watt is same as 10 kilowatt. All right, so that is it. Next question. Okay, so I have another question here. Let's do justice to this one. So this actually goes this way. Okay. A bullet of mass with 0.1 kg is thrown vertically upward with a speed of 10 meter per second from the top of a tower 10-meter high, neglecting air resistance, its total energy just before it hits the ground. Okay. Now this is a kind of a tactical question. So from I what I've read, a bullet of mass 0.1 kg is thrown vertically upward with a speed of 10 meters per second from the top of a tower. So that means this bullet was fired from the top of a tower. So it's now returned directly to the ground. Okay, so from what the question stated, the mass of the bullet is 0.1 kg. So, and okay, what again do we have? This speed, that is the initial velocity. Okay, the initial velocity of the bullet was thrown with 10 meter per second as the initial velocity. Okay, then of course, this tower is said to be, the height of this tower is said to be 10 meter. So now the question is total energy just before it hits the ground. So you're looking for the total energy just before this particular object hits the ground. So invariably now you're looking at an object that at this point falls down to the ground. First of all, it reaches this maximum height before it now gains uh, potential energy, all right, which now leads to it falling directly to the ground. So how do we evaluate that? So if we need to evaluate that, that means we need to get the height. Remember the kinetic energy, okay? Because that's what we are being asked for. Okay, it's total energy. The energy at the point where it hits the ground is the kinetic energy. And that kinetic energy came from the initial potential energy. I've talked about that. Okay? Which of course is equal to mgh. Now the height I'm looking for is, let me use capital letter H, okay, for this height. Remember there are two heights. The height I'm looking for is the height all the way from the maximum height, okay, maximum height to the point where it reaches the ground. But there's another height, and that height is the height from the top of the tower to the maximum height. Let me use small letter h to represent that. Okay, so which simply means that if I want to get this height, the height all the way from the maximum height to the ground, which is capital letter H, is going to be equal to the height of the tower plus this, the height of the tower, okay, which is 10 meter, plus this small letter H, the height from the top of the tower to the maximum height attained by the bullet. So the question is, how do I get this small letter H? Okay, for me to get a small letter H, I have to apply, okay, the equation of motion under gravity. Remember, I've, at the maximum height, you should know very well that the final velocity is equal to zero. Okay, we've done this before. We also know that my g still remained 10 meter per second square. So what I'm looking for now as my unknown is small letter h. So given this parameter u, v, g, and h, which equation of motion do I need to apply that will enable me find this h? I know very well that the equation of motion under gravity I need to apply that carry this 1, 2, 3, 4 parameters is the third equation, which of course is v square is equal to u square. Okay, so it's this upward motion, so that's going to be minus 2gh. Okay, it's going upward, so against gravity, so I'm using minus here. So just in case you've forgotten this, you go back to our video on the motion under gravity. So let's start putting our values. Of course, v is 0, so I have 0 square is equal to u square, which is, according to the question, the u, okay, is 10 meter per second, that's 10 square. Then minus 2 times 10 times h. Okay, so if I should take minus this 20h, take it to the rest of the equation, it becomes 20h, and 10 square is 100. So invariably now my h is going to be equal to 100 divided by 20, so which is 5 meter. So the small letter h is 5 meter. So that way now, the total height, the capital letter h is going to be 10 plus the small letter h, which is 5 meter. So I'm having 15 meter. So I can now evaluate the total energy from this maximum height down to the ground level, which, okay, I'm going to apply this formula. So the total potential energy, mgh, that's going to be equal to the mass. What was our mass? 0.1 times by times g10, of course, times 15. 0.1 times 10 is 1, 1 times 15 is 15, so the energy is 15 joule. So I hope that is well understood. All right, next question. Okay. I think I've actually come to the end of the question. Okay, so see you in the next video. Thank you very much.